Subscribe to my channel.
Everyone, today's topic is RRC Inactive. So RRC Inactive feature in 5G. So RRC Inactive state is not just a battery saving trick. It is a structural necessity designed to fix specific bottleneck between 5G radio access network and 5G core. Here are the exact 5G specific problem that RRC Inactive solve. So, so improvement here is the points. So improvement is efficient battery saving, faster connectivity, reduce signaling load, flexible paging cycles. So next is states, three states in 5G and RRC Idle, RRC Inactive, RRC Connected. So RRC Idle here is no access context, no as context in UE and G node B because in idle mode access stratum means the conversation strictly between your phone and the local tower means G node B over the radio waves, and non access stratum means the conversation directly between your phone and main core networks. So here when UE in RRC idle, so no access stratum context in G node B, and second things is DRX for paging monitor. So monitoring through the DRX and cell reselection by UE in idle mode, and core network paging is happen in idle mode. In these states, all this functionalities is working, and the new functionalities in the new state is RRC inactive. So in this state, AS context is stored between UE and anchor G node B. Next is RRC inactive. In this state, access stratum context is stored. Means UE information is stored in the G node B. And second point is RNA based paging area. RNA based means uh, rain based notification area. It is a designed geographical zone assigned to a device means mobile phone by the local cell tower means G node B, especially when the device is placed into the RRC inactive state only. So when idle state, suppose you move around the in a idle state, so in that case it has update the main core network every time in idle state. It cross the boundary called tracking area, so it will be updated by UE, but in because this state is RRC inactive, means it hides or hides the device's sleep state from the core network. So the local radio network means RAN take over the responsibility of tracking the devices. So in inactive state, we can say the RNA is means radio access network takes over the responsibility of tracking the device. So RNA is a local zone where the phone is allowed to roam freely without telling the network. So how it works means in 5G core network, suppose receive the WhatsApp messages of your phone, it forward to the data to the last known cell tower, means your anchor G node B. Since your phone is asleep, so the anchor G node B doesn't know the exactly which specific cell you are currently standing under. Therefore, G node B triggered rain paging. So that's why here is the second point is rain paging. So rain paging ID is here. So how rain paging IDs work? So whenever uh, so what happens when uh, you jump out of the your assigned rain area when your sleeping phone check the local cell broadcast and realize it is in a new unassigned area, so it is strictly required to perform RNA update. So the phone briefly wake up and sends an RRC resume request to the new cell tower. So it effectively say, suppose I have moved outside my boundary and tell my older anchor tower where I am and give me a new RNA. Means give me the new radio network. So ID will be updated here through the rain based notification updation. So the network update the phone location, give it the new RNA boundary and put it right back to sleep. So rain based paging is required and ID is required and rain and DRX inactive state is also there. So and third is RRC connected state. It's a fully AS context active and dedicated radio resources are using here and active data transfer is here and handover procedure also be in RRC connected mode. So next is the problem statement. Why RRC inactive was introduced? So as we know the in RRC idle lower power consumptions, minimal signaling overhead in idle, no G node B context storage is there uh, in idle conditions. And if we talk about the negative points is high latency on reactivation, full NAS plus RRC reestablishment required, core network paging load on every connect, and in RRC inactive state is a lower power requirement as context preserved in this as context bearer configurations and security key is there in this context and fast resume, no full reestablishment required like idle, and rain paging as required, no core network load is there. And it's a negative point is rain context management overhead, means uh, GNodeB has to manage the context um, details and rain update signalings, which is earlier we discussed the rain updates whenever you move from the one rain area to other rain area. So UE has to send the resume request and update the GNodeB for the new rain ID. Next, RRC connected. So here lowest data path latency, full QS immediately available, no setup overhead, highest power drain, negative context, constant resource allocation is required and not scalable for IoT busty traffic. So benefit is here. Transition a UE from RRC connected to inactive is a faster than moving it to RRC idle, resulting in improved battery saving. The UE can resume RRC inactive to connected more quickly than RRC idle, enabling lower latency for services. Signaling overhead is a reduced when transition from RRC inactive to connected compared to transition from idle to connected. This feature is a key enabler for emerging 5G use case that required low latency like wearables and IoT devices. And it also plays a crucial role in meeting 5G requirement for enhanced battery efficiency. And yes, now suspend and resume procedures, how it will be work. So RRC connection suspend and resume. Suspend means connected to inactive mode. Gnode we decide to suspend UE means inactivity timer should be enable or trigger. So it will be the it would be configurations. So we can enable inactivity timer there, and whenever this timer will be trigger and uh, Gnode we decide to suspend UE, and Gnode we send RRC release with suspend config. Suspend config is uh, eyes where we can see short RNTI and 4 RNTI. We can discuss later. So suspend config have the IRNTI and next hopping chain count, rain notification area info, and T3 at 0 timer is there. And fourth is UE store access system context means PD, CP, SN, and security parameters. Fifth point is UE transition for RRC inactive and NGAP. So UE context suspend request. So AMF retain connected. Now the resume means inactive to connected. So UE send RRC resume request on PREG and RRC resume request IRNTI plus resume make I is a 16-bit, and so Gnode we verify first make I fetch context which is stored in the RAM already, and so via action if needed, and Gnode we send RRC resume master key updates radio bearer config means Gnode we sent RRC resume to the UE. UE send RRC resume complete, and then NGAP UE context resume request to the AMF reactive the end-to-end and 3 interfaces. So it's done. And next is RAN based paging. When paging will be happen. So RAN paging for UE in RRC inactive. So here DL data is arrived at Gnode B. So anchor Gnode B initiate RAN paging. So paging message broadcast over the RAN and through the PCH, and UE detect PRNTI on PDCCH, and UE sent RRC resume request if DL data is arrived on Gnode. So the parameter is here the IRNTI, means whenever RRC release with the suspend config, so we can see the 40 bits UI identity in active state, and paging cycle, it will be SIV1 paging cycle, DRH cycle will be 3264 as per 120 128 256 radio frame, and the subframe per paging cycle is NS in sub1. Paging frame paging occasion calculations, and RAIN area code, which is in SIG1. RAIN area code, and identify the RAIN RNA within a tracking area. So next, in coming slides we can discuss the RNA. Here is the RRC inactive summary. In this summary, the RAIN determine when you should transition from RRC connected to inactive, and this transition is triggered using RRC release message with suspend config. And so in this inactive RNTI, handling this two types of RNTI are used: Gnode B identity portion, upper bits, and the lower bits will be UV specific portion. So here is the full RNTI 40 bits, short RNTI 24 bits. If use full resume ID, if use full resume ID is indicated as SIB1. Okay, when we have to use full RNTI and when we have to use short RNTI. If use full resume ID is indicated in SIB1, the UE use full RNTI. So first check what the SIB1 is telling. Otherwise, it use a short IRNTI in RRC resume request. Okay, so the answer is when you have to use the 40 bits and when we have to use 24 bits. So we have to check the SIB1 use, if there is a useful resume ID. So we have to use 40 bits. So RRC resume request when the Gnode B has configured short RNTI uses in the cell. So the UE resume in a cell that part of the same Gnode B. If we are not moving anywhere and for still in the same Gnode B, so no need to full RNTI. And if if I use full RNTI in 40 bit, so I will send RRC resume request to 1. Okay, whenever I use 40 bit short RNTI, you will send RRC resume request. Whenever you send full RNTI 40 bits, you will send RRC resume request. So you has moved to different Gnode B, means you has to move different Gnode B from anchor Gnode B. So the new Gnode B needed full 40 bit RNTI to identify and the context the anchor Gnode B over the accent. That's why required the full 40 bits. Suspend config includes assignment of both full and short RNTI, configuration of RAIN paging cycles 32, 64, 128, 256 radio frame. So this suspend config includes this all eyes. So first, short or full RNTI configuration of paging cycles, define a RAIN notification area, and based on the cell ID and based on the combination of tracking area code. In coming slides we can check tracking area code also. And timer is 1 at 30 timer act as a keep alive mechanism for UE when it remain within a configured RNA. Here is states how we will moves to RRC inactive and from RRC inactive to RRC connected state. So first image in left hand side it's saying the RRC connected to RRC release with the suspend config by the network, and whenever you resume request or resume request 1 sent by the UE. And if still we are in the inactive state and timer will expire, so it will be in idle mode. From idle mode, it's in the right side message picture is denoting it's if once you move to idle mode, if it wants to connected mode, so required RRC setup, full configurations required, NAS and S. Here is the RRC resume plus RNA update message flow. Here first we can see here is a timer is expire, and move out REN notification area. So first if UE has to send a resume request 1 or resume request, so that time resume cause if C1 in C1 has use full resume ID is true, then UE will use RRC resume request 1. Otherwise it will be short RNT is required. And resume request, resume response, it will be the connected state. Oh yes, here is a behavior in RRC inactive states, UE behaviors. So first, mobility handling, how mobility will be handled. So idle, like idle means if you in inactive state, and how the mobility will be handled. So the while RRC inactive, UE follow the idle mode mobility procedures. This allow UE to perform cell reselection without network involvement, means like idle. So while a RRC inactive, the UE follow idle mode cell reselection procedure. UE autonomously perform cell selection without network involvement as long as it remains within its configured RNA. So intra-frequency reselection, so parameter and threshold from SIP2. So intra-frequency reselection, so you will get the parameter from and threshold from the SIP2, neighbor cell list from SIP3. If its mobility is interfrequency reselection, so neighbor cell list and parameter from SIP4. So here we have to discuss first RNA part. So one log is here. So first RNA notification area based. So here RNA notification area based upon cell identity, REN notification area based upon cell identity. Here AMF and UPF means here anti signaling connections, GTPU tunnels, and these circles denotes the cell IDs based upon cell identities. If REN notification area based upon combination of tracking area code. How the REN notification area confirmed or making by these two entities. First tracking area code, second is REN area code, means REC. So these two entities, when we combine, it define the REN notification area. So here we can check take ID 1, take ID 1, take ID 2. Okay, so where is the take ID? Take ID 1 and REN area code is 1. So if mobile is or U is here in Tech 1 and Rec 1, and it move from Tech 1 Rec 1 to Tech 2 Rec 2. So a REN notification area will be update through resume request. So REN notification area define the reason where UE can be paged. So REN identify the UEs through the REN notification areas. So define the reason. So REN notification area define the reason where UE can be paged. Means when the RRC inactive state, REN determine RNA determine radio REN notification area determine can be based upon either cell identity or combination of tracking area code or RAN area code. So this is the clear for RAN notification area how it will be work. And one more message is here. So we talked about the RRC release message whenever you moves to inactive mode, or whenever we send the RRC release message with the suspend config. So these two entity will be sent, full RNTI and short RNTI, and REN paging cycle and REN notification area, which is we discussed here. So here is the cell list, which is the cell list, PLML ID, MNC, MCs. So now the so mobility, for the mobility handling we already discussed. So if we are use intra-frequency reselection, so SIP2 and SIP3 are required of if we are using inter-frequency reselection, SIP4 is required for the neighbor cell list and parameters. Second, REN notification area validation. So after each cell reselection, the UE checks whether the new cell belongs to its configure REN notification area. So UE check whether a new cell belongs to its configured RNA. First case, so UE remain within the same RNA. So if it is not, it will be initiate resume request. So no signaling is triggered. You stay in RRC inactive and continue monitoring paging. You move outside the REN. If you remain within the same RNA, so no signaling is triggered. You stay in RRC inactive and continue monitoring. If you move outside the RNA, you must inform network by triggering a RNA update procedures, which is we discussed. Resume procedure for RNA update is you is read SIB1 first. If a new cell to check a parameter, if use full resume ID is there in SIB1, it use the resume request 1 and use full RNTI 40 bits as UE identity, and resume request cause will be REN update. So these two parameters is required. If use full resume ID is false, suppose that time you will send RRC resume request only and use resume cause. What is the reason of resume? So reason is REN RNA update and short RNTI as UE identity, because it is in the same RNA REN notification area, so no need to required full RNTI. Fourth point is time-based trigger, means T3 at 0. The T3 at 0 timer act as a periodic update mechanism. When T3 at 0 expire, UE trigger RRC resume procedure with resume cause REN update. So this is the points for UE behave in RRC inactive state. Mobility, we check the mobility handling, how mobility will handle, Rain notification area validation. How validate the rain notification area? Um, how you will validate if you remain within the same range, so no need to trigger the signaling, and you stay in the same and you stay in the RRC inactive and continue monitoring the paging only. If you move outside the range, so it's required to rain update procedure start, and for this procedure you have to send the resume request. And if you will send the resume request to IS will be sent, which is a resume cause and a full or short RNTI. In resume cause we use, so we have to send RNA update as a cause. Now rain based notification area. So RNA and RNA update procedure, how it will be. So suppose that I am in the cell 1 area. Okay, in cell 1 area come under the RNA1, which is the my anchor G node B. Suppose that in my anchor G node B, cell 1, cell 2, cell 5, cell 6 and cell 9 in one anchor G node B, means one RNA. If suppose that at RNA means different RNA area, cell 3, cell 4, cell 7, cell 8, cell 9, 10, 11, 12. So these two different RNAs is there. So if UE moves RN1 to RN2, so UE has to send RRC resume request with the cause rain update with the IRNTI, and to the new G node B. Here is we written here new G node B. So new G node B use action contact action interface and fetch the context detail from the old G node Bs, and RRC uh, release new suspend config plus RNA update will be given by the new G node B, and UE returns to the inactive. This is the procedure. It's a rain update flow. U is still in the inactive state. If we move from one RNA area to another RNA area, it just resume request, send the resume request is the cause, rain update with the RNTI to the new G node B. New G node B use the Excel interface and fetch the context details, and new G node B will send RRC release to the UE with the new suspend config, in which full RNTI and short RNTI will be there, plus rain RNA means rain new rain IDs, and you return to inactive. So rain update trigger, you move from to cell not, you move to cell not in RNA. So RNA notification config timer is expired, UE enters connected state, and cell not broadcast RNID upper layer indications, all this will be triggers. So here is the RNA update call flow. So UE in inactive, so inactive to active, so PRH message will be work here, PRH channel will be work, and send the message 1, and message 2 here temporary CRNTI will be given in message 2, and RRC resume request will be sent through the UE, and RRC resume request its a flow is like RRC idle only, because whenever we uh, sync in uplink or connect to the uplink, so PRH will be sent and get the RR message, and then RRC request will be sent. So here same RRC resume request we are sending to the G node B, and the eyes will be the IRNTI resume make I cause will be the rain updates, and anchored G node B, non-anchored G node B. Non-anchored G node B means new G node B. Confirm to the anchored G node B, old G node B, and retrieve the context details through these are IRNTI, because this UE knows by these IRNTIs only. So G node B send based on this IRNTI, send the context details, PDCPSN, security keys, and verify resume MAC-I. Then new G node B will send the RRC release with the suspend config. In this suspend config, new IRNTI will be provided by the G node B. New RNA config, REN notification area config will be sent, and T38 new 380 provided by G node B, and next hope chaining count. Now return to the inactive, and this information also will be update to the action interface. UV context will be released. So here is the point flow. Now is overview. We can check the overviews. Here the functionalities. What is the functionality present in idle, and what is present in inactive, what is present in connected. So the comparison is mostly between the RRC idle and RRC inactive. So UV context at the G node B, not present in idle conditions, but present in inactive conditions. RRC connection between G node B and UE, not present in idle condition. No connection is there between G node B and UE in idle condition, but in active state it will be not there, but in RRC connected state it will be there. RRC connection between G node B and UE present in connected state. NG-UE specific signaling between G node B and AMF, not present in idle, but present in inactive and connected mode. GTP-U tunnel between UPF and G node B, not present in idle, but present in inactive and connected mode. Mobility procedure, registration area update happen during RRC idle, but in RRC inactive state, RNA update will be happen. This these things is different. And in corrected procedure, G node be taken the handover. Paging for reachability. So core network initiate the paging in RRC idle. In RRC idle, core network initiate the paging using the STMC. So in inactive state, R RAIN initiate the paging with IRNTI. It's noted that RAIN initiate the paging with the IRNTI, not core network will initiate the paging. Core network only sent till G node B. Mobility, cell reselection mobilities happen here. This is the same things happen in RRC inactive. Same procedure follow in an inactive procedure, in active state. Network control mobility, RRC connected state. So it's a network control mobility. So next, core network assistance information for RRC inactive. So this information is provided by core network to support efficient UV management in RRC inactive state, particularly for paging, mobility, and resume procedures. UE identity index value. First point is UE identity index value. So represent UE identity index as a defined 3GPPTS 38.304 used to determine UE's paging frame and paging occasions. So how identity the UE? So use to determine UE's paging frame and paging occasions. So enable efficient RAIN initiate paging. So enable efficient RAIN initiate enable. So UE is RRC inactive. So the this value is forwarded from CUCP to DU over the F1C interface for the paging coordinations. So first point will be clear. First, enable efficient RAIN initiate paging while the UE is RRC inactive. This value forwarded it from the CUCP to DU over the F1C interface for the paging coordinations. Second things, periodic registration update timer. So indicate how often the UE should perform the registration update with the core network. Okay, it's required. So here, uh, if timer 3T timer is expire, if it is expire, means RRC resume request will be sent, and this resume request RRC resume request goes to TU core network, and RRC reconfiguration or RRC resume will be happen. List of tracking area codes. So define the set of tracking area associated with the UE registration area. Help a RAIN helps the RAIN determine and configure the RAIN notification area for the UE and ensure the paging and mobility handling are aligned between the core network and RAIN. So list of tracking area codes are required. So in these pictures, here is the list of tracking area codes, tracking area 1, tracking area 2s, like that, and tracking area with the rec also is there. Now next is so next is UE capability handling. How UE will be handle the capability is so the UE indicates support for RRC inactive state via parameter. So the CUCP retrieve this capability during UE capability exchange, store it as a part of UE context. Only UEs supporting this feature can be transitioned to RRC inactive. So second point is AMF play the key role by providing core network assistant information for RRC inactive via the NGAP message such as initial context setup request. So core network also play the key role for this inactivity. So this initial context setup request, UE context modification request, path switching request acknowledgement, and handover request. If this information is provided, the G-Node B can transit from to RRC inactive state of the idle. instead of idle. G node be impact for RRC inactive state. Behavior without RRC inactive feature. So when the feature is not enabled, suppose so CUCP relies on in activity monitoring using so activity not if level UEPD PDU session DRB level, and the CUCP configures UE inactive timer, send inactive monitoring parameter to the CUCP during the bearer context setup procedure. The CUCP monitoring activity at configured level UE PDU or DRB release resources upon the detecting inactivity. As a result, UA is fully released and transition to the RRC idle state. So already we discussed this REN notification area, cell identity, and notification area based upon combination of tracking area code. So here is the UE capability informations. In this UE capability informations, if UE support inactivity, so inactivity state it supported is here, and whenever release the RRC release happens, so in release suspend config is there, full RNTI, short RNTI, RAN paging cycle, and then notification area informations. And timer will be configured T380 also in release, and paging for the paging IRNTI will be sent through the paging. RRC resume request happen if suppose that in paging DL data notification is received. So UE will send the resume request message. So resume request message, the here is the IS. So information elements resume request identity. So which is IRNTI 24-bit or 40 bits. MAC I 16-bit values, and resume cause empty access means we have received notification DL data, so empty access. So here is the resume request logs. Now full IRNT allocation mechanism, how it will be allocated. This is the mechanism, and new REN level identifier called full IRNTI is configured at the G node B. Full IRNTI is a 40-bit identifier used to uniquely identify a unique UE in RRC inactive state. Structure and concept is full RNTI is logically divided into two parts. NG REN node identifier, which is a G node B specific part, and UE identifier within a G node B UE specific part. So this is a profile 0, 1, 2, 3. This is the profile number of bits required, and this is now. Thank you for watching. Please like and support.
Don't forget to subscribe.